In this problem, we have information about two different points in time. T is the number of years since January 2nd, 2025, and we are first to write the value of the car, not the building as accidentally typed here, as a function of T. So what we need to do is, since this is showing value depreciating linearly, write a linear function. If we were using y and x, then we would have y equals mx plus b, i.e. f of x equals mx plus b. But here we have the first point is at the start, 2025 is the year zero, and the value is $49,000 at that time. Our second point, we have information about the value on January 2nd of 2029, which is 4 years later. So we have a second point, 4,25,480. We're going to first find out what the slope of that line is. Instead of y and x, we have values in place of y values, value of the car, and we have times instead of x's. So we have the $25,480 minus the 49,000 over 4 minus 0, showing the subtraction on each. Let's see, 25,480 minus 49,000. That's negative 23,520. It's happening over 4 years. So we have negative 5,880. That is our slope. And our first point, again, if those were x's and y's, then on a graph of the line, we would have a y-intercept from that first point, since the x-coordinate would be 0. But here we're talking about a v-intercept. So v of t, since it asks for us to write a function instead of just an equation, we have this. And note that the slope that's representing that each year is going down by $5,880. I'm just double checking my values here. All right. So then how much will the car be worth on January 2nd of 2027? So this was our work for part A. And for part B, we're talking about 2 years after the start. So we are computing V of 2. Now I've got some more room to write. Doing the multiplication, we've got that it's gone down $11,760. But since we started at a value of 49,000, value that it is at now would be $37,240. Notice how I've included what it's being measured in, that it's being measured in dollars.